gentlemen, welcome to the future. We are now in the last part, on the second part of the presentation, where we should deal with future technologies. Tools are a prerequisite of our current advanced combustion technology. And this new kind of combustion is coming out of looking on the process currently, like the diesel and gasoline combustion is changing. If you come from the gasoline engine, we see that the gasoline engine had already an absolutely homogeneous combustion in the past by injecting in the tailpipe and then have a lot of time for homogenization. Now we are changing or switching to direct injection engine. We're adding turbochargers, so we get slightly stratified, but again, in adding the turbocharger, we step back to a homogeneous mixture, but it's we have only short times for mixture preparation, because we are direct injection and not port injection. The latest step we are currently realizing in our research department is the auto-ignited gasoline engine. So we wouldn't need any spark plug for firing such an engine. It's auto-ignited, it's lean burning, and it's NOx-free in this lean burning operation. This is the latest step. So it's very near to how currently diesel combustion looks like. And if you come from the diesel side, it's just the opposite. The diesel side came traditionally from stratified injection. So it's an unequal, inhomogeneous mixture preparation. We are living from the inhomogeneity of the mixture, the fuel and air distribution. And now switching in the latest step, as demonstrated in the US concept by my colleague, leading to a partially homogenized combustion. So at low particles, we are able, even with diesel fuel, to homogenize the mixture, and so dramatically reducing NOx and particulate emissions. Now the idea which is standing behind our future combustion is that we put those two series together and combine each component from the diesel and the gasoline in a new kind of combustion which is homogeneous, which is direct injection, which is auto-ignition, and which needs a turbocharger. And this combining together with a new kind of fuel which has been optimized for such a combustion process. Because it couldn't be optimum to drive the same combustion process with two different fuels. This couldn't be the optimum. There always must be one optimum which is higher than the other two in designing the fuel which is exactly fits in such a combustion process. This is more a description how we realize such a combustion. On the left side you see the traditional TDI combustion. TDI is a late injection, very near to top dead center. Late mixture preparation, so only short time. This leads to an inhomogeneity in the mixture preparation and leads, unfortunately, to soot emissions and NOx emissions. On the right side, we have the homogeneous driven direct injection gasoline engine. We are making absolutely early injection during the inlet stroke, combust the mixture, so we have huge time for homogenization and mixture preparation, and then igniting this homogeneous mixture with a spark plug, again near to top dead center. In the CCS program, this is a combination of these characteristics. We are somewhat in between. We make a much earlier injection as in a traditional diesel, but later as in the traditional TSI engine. So we get a partial homogenization. It's as homogeneous as necessary. So we are injecting as early as possible and as late as necessary. So it's just looking for a good compromise in between. And this is the secret behind. Most of the people who try to realize an HCCI combustion process make an extreme early injection and wondering whether they had bad fuel consumption. We have an optimized combustion because we just in the position that we have enough homogenization but still able to control the combustion a little bit with the injection timing, but mainly with the composition of the gas. We are using EGR ratios up to 90% in some points, though the most of the combustion behavior has been performed by the composition of the gases. This is the factor how we control it. Just to demonstrate what is a visualization of the benefits of such a combustion. On the left upper part, you see the traditional diesel combustion. Two injections, pilot and main injection. you can recognize the swirl, and the stratified fuel distribution leads to this lightning during the combustion. What you see is more or less a so-called soot lightning. During the first time in the combustion, there is a lot of soot being produced, which is oxidized during the later timing during the combustion. And during this oxidization of soot, it's sending out a red light. And this is what you're seeing here, though it's typical for soot oxidation that you get a slightly red light. This is an indicator for soot emissions, but also on the outer shape of such a flame you have extreme high local temperatures which are exceeding the NOx forming temperature of 2000 Kelvin. So this flame, it's not only an indicator for soot emissions, it's also an indicator for NOx emissions. Innerly in the flame there is soot, and on the outer shape there is a NOx. Now just have a look on this new combustion system CCS. You see that you see nothing. Absolutely nothing. You see the two injections, and later on injection is not, combustion is not visible. It's an absolutely, completely 100% premixed flame, which sends out only invisible lights. It's in the blue range, which is not visible for your eyes. You only could recognize this with an infrared camera. And this is a signal that we were really able to fully homogenize the combustion, and that we don't have any soot production, and at the same time no local temperature above 2000 Kelvin, which means there is absolutely no NOx formation. Now this combustion is free of NOx, free of particulates, and is, as you can see on the pressure curve on the right side of the picture, it's an extremely efficient process because you have very very rapid pressure increase, which is normally an indicator for good efficiency. This process is roughly 8% more efficient than our today's diesel engines. So we have three major points we want to have, which are prerequisite for sustainable future. It's free of NOx, it's free of particulates, and it's more efficient than today's engine.